we'll begin here. I want to welcome everybody to the monthly interoperability and technology webinar series, Tech Dive series. I like to start on this page all the time just to remind people that this is our web page, and if you want to join the IT&I mail list, you can join it here. I have been sending these to ESIP All and to several other groups, but really, you know, if you want to, I guess that I'd like to stop doing that because I figure if you really want to hear about IT&I stuff, you should really get on the IT&I mailing list. I don't know, Aaron or Annie, do you feel, how do you feel about that? You know,
I think that's probably a good plan. You know, maybe quarterly reminding ESIP All now that things are going regularly, and you know, it's going out. I saw that Annie tweeted it this morning, so it's, you know, things are going out through other channels too. Right.
So I don't want to spam people. If, you know, ideally they'd be on the list if they want to hear about IT&I stuff. So anyway, so maybe I'll send out one more reminder next time. I'll just send a reminder to everyone to get on the mailing list if they want to keep getting notified about these talks. So anyway, our main activity on this is right now is this webinar series, and if you click the link here, takes you to our page where we have all the talks that we previously had along with the recordings and the slides. The next talk, actually, I don't have on here because I haven't confirmed it yet, but it will be September 8th, and it's probably going to be the Apache Open Climate Toolkit, sort of continuing on this sort of types of tools for dealing with climate and other related model output and gridded data. So today we have Charles Doutriaux from Lawrence Livermore talking about a package that's been around for quite a while. It's very mature, the community data analysis tool, CDAT, and it's sort of morphed into even a bigger project, as I understand. So getting kind of an update from Charles on this project, and for folks who are not familiar with it, you'll get an introduction. So I'm going to make you the presenter, Charles.
Okay.
And let's see here. Okay. So you should be able to share your screen.
All right. Can you guys see it now?
Looks good.
Looks good. Okay, so yeah, I'm going to talk about UVCDAT or CDAT. We're just kind of in the phase of like changing the name a little bit. But basically this climate data, community data analysis tools, it used to stand for climate data analysis tools, but we're more going to our community data analysis tool now because we are going away from supporting just climate, you know, more like general analysis, so for any community. So I will go quickly talk about, you know, which kind of OS and hardware we support, general work environment, setup, and then examples. And I'm going to try to keep it somewhat open discussion near the end, so you can ask questions and I can maybe like just do more demo, because I think for software it works better to actually show what it does than just talk about it. In general, people believe it better like that. So as far as OS and hardware, we are supporting Mac and Linux only at the moment, which is for Linux, Red Hat, and Ubuntu, but pretty much any Linux distribution. And we're planning on moving to Windows. It's just a matter of lack of resources to really do the port than anything else. Environment, we recommend Bash. You could use TC Shell, but because we're using Anaconda, Bash and Z Shell are just really nice fit for Anaconda, and TC Shell, it works, but it needs a little more work on the user's hand, so we recommend Bash or Z Shell. So to install it, that used to be like the biggest hurdle to use our software. It used to be to install it because we used to install from source, and it's massive. It's hundreds of megabytes of source code to compile, and it would take time, and it would use so many externals that it would pretty much systematically fail, or, you know, we need at least us to get you an input. But now we switch to Anaconda, and it's literally pretty much as easy as just do a conda install UVCDAT using our channel. So that's much nicer. It's just super simple now to install. Again, Mac or Linux only. Then you need because it's using Anaconda, you just set the path to your Anaconda binary in your path, and you just source activate your environment if you use an environment for Conda, and you're good. So these are more like for reference for later, but the documentation comes from the UVC.dat webpage. Maybe I should just show you quickly, uvc.nl.gov. And so here you have everything from with installation I was just mentioning, and a little bit of documentations and everything. But all these links are in the presentation, which will be online soon. How do I go back to present like that? Maybe. Okay, good. Oh, and we have the galleries. I should have shown the gallery. Yes, I forgot to. But the most important to get started is going to the gallery right here, and you basically have a bunch of like plots, and you can kind of matplotlib sort of gallery. And let's see, you can filter. Try to get a nice one. Oh, here we go at the bottom. So you have a plot, like let's say you want to do this sort of plots. You can look at it, and here you have the script on how you would do that. So that's a nice part of it. To follow up with the documentation, because it's kind of what you want to go back later, we document different parts of the software. I will get into this in detail. I have links to this GitHub website. Is actually really good. It shows real actual scientific use by scientific community. So you can look at the picture. We need to format that in a better way. But see, you want to do Blue Marble with your data on top of it. And if you want to know how to do that, then you have the script that would do that for you. So these examples are nice because they're actual real-life examples from things that scientists do, so they have a lot of value to them. And also another presentation with some more in-depth tutorials about CDAT. Really so the basics for our software, they have a few parts. We have I/O, and it's using the climate data management system package for that. And all of the analyses are basically built on top of NumPy, which is basically the one and only numerical package for Python. I mean, there's others, but that's the one that everybody is using. And because we live in using data from the real world, there's always missing values. So we are actually even using something inside of NumPy, which is numpy.ma, which stands for mask array, which means not every part of your array actually has data. And so that's able to do handling missing value properly. And because having just numbers is not necessarily always useful, we own class on top of that, which is masked variables, MVs. And what these variables have, they have metadata information associated with them. And I think I have a slide on that. I will come back to that. But that's basically telling you, what is this number? Is it a cloud? What are the units? And what's the domain it's in? Axes and grids and things like that. So, and having that associated with your array allows the software like UVC to do smart decision for the user and simplifies life a lot. Then on top of that, we have a bunch of utilities that we developed in-house over the years. And we split them in basically two packages. One is a GenUtil package, which is for general utilities, which means they're not related to climate specifically. So things like subselection, color manipulation, or statistics, things like that are in GenUtil. And we have the CDUtil, which stands for climate data utilities. And these are more regrading, averager, everything that is more climate specific. As far as graphics, we have our own VCS, which stands for Visualization Control System. And it's really, really good for geodata, basically, for plotting data, Earth data. But it also comes with Matplotlib because everybody, using Matplotlib as well in Python world. But we don't support Matplotlib by ourselves. We just distribute it, Matplotlib and Basemap. So to get familiar with UVC CDAT, one thing that's really good at the beginning is a GUI. We have a GUI called UVC and if you type that, you bring the GUI up, and that lets you basically do rapid exploration of your data locally. And you get a little script, you can see what you do, everything is toggled, and you can learn about all the specific tools of the system. It's really nice to get started when you don't know anything about it. You can quickly get a look at your data and get an idea of how you would do it from the command line for scripting. Now this GUI is basically, you know, like a desktop application, and because we live in the 21st century, we are kind of going away from having simply a GUI, and it's going to be browser-based now. So we don't have a GUI, and the browser will be able to talk either to your local installation or to a server, and we'll have a bunch of servers everywhere that will allow you to do visualization of data locally or remotely. So the GUI is kind of going away and being replaced by simply like a browser, which also makes installation easier because everybody has a browser on their system. So I'm going to do a quick example. You have it here, and what it does, I'm going to go line by line over it. So that will get us the basic of what we do, and then I think at that point I can show more detail of other modules and get questions in. So the first line is import CDMS. So as I mentioned earlier, CDMS is our in-house reader, and it lets us read a lot of different formats, mostly like a climate community format, but like NetCDF, which is one of the most common format, PP, GRIP, GRADS, GRIPS2, even DRS, which is a very old format that we had before in NetCDF. So that's nice because that allows user to keep, at least in the community, for the most part, they don't need to rewrite their data to use our system. You can just load them up using CDMS, and it's one library for every format. So that's nice. Then we do import VCS, as I mentioned earlier. VCS is our plotting module, and it does 1D, 2D, or 3D plot. It's extremely customizable, and you can get publication quality plots, and you really have control over every element, every aspect of the plot. And it output to a lot of formats, mostly like, you know, PS, PDF, PNG, SVG, switches, vectors. So that's a nice thing. Then we import GenUtil, which, as I mentioned, is our general utilities module. I have put a link to the documentation in there. Then I import OS, which is a Python standard module for file manipulation and anything on your OS. So now I'm constructing the file name string of the file that I'm going to read in for this example. VCS comes with some pre-canned sample data, so I just say VCS.sample data, and that will link me to the data that come with the installation. And then I do CDMS2.open and this file name. So now I open this file for the data, and the file is ready to be read. Now the next line, I'm going to read in some data, and we start to see some power here. So with this file F that I just opened, I tell him to read the cloud, CLT is cloud, variable, and you can notice that I tell him to read just 1 year of it, 1981, basically from 1981 to 1982 open. So and that already shows you the power of using CDMS and having metadata associated with your array, because you don't need to know because the data has all these units and metadata associated with it in the NetCDF file, we let the software figure out when is 1981 in the file. You can have 200 years worth of file in it. It can be monthly, it can be hourly. CDMS goes in, figure out the dimensions, understands it, and now gives you just the 1 year you want. And you can go through a lot of different files with different time units, time calendars. It will extract all your data the same way. You don't have to have a, if it's model A, use index 1 to 12. If it's fruit 13, and if it's model B, then use index 1000 to 1012, things like that. No, it just does all that automatically for you. And it's not just for time, it works for latitude, longitude, any dimension with units. You can basically subset it exactly the way you want. So that's a lot of smartness done for you here.
Charles, just a clarification.
Yes?
Clarification.
Yes.
Is that a lazy load, or are you actually loading data there, or are you, you know?
Okay. So in this specific case, yes, because I have round brackets, and I also selected a subdomain. So this I'm actually loading the data in memory. If you do square bracket, then you have just lazy, like nothing happens. You can query the data and figure out what's in it.
Okay.
But in this case, I'm loading it 1 year worth of data in memory.
Okay, but you can do either one. Okay.
Yes, you can do either one. Except once you start the subset, well, it's instantly ready. It's something we want to do. It's part of our rework for version 3. We want to have way more lazy evaluation, like really just in time, like when you need it, read it.
Yeah.
But we're not, like this is when you start to subset, we read it in memory.
Okay.
Okay, so the next line, I'm actually going now to compute a standard deviation over this data. So, and I'm telling him here, I want to compute this statistic standard deviation over the time axis. And again, that's the power of the metadata and having this array with metadata associated with him, is that now I tell him, compute the standard deviation over the time axis. And I don't have to know if time is my first dimension, my second dimension, my third dimension, it doesn't matter. CDMS, the UVC is going to figure that out for you and compute a standard deviation. And that's useful because, again, your data are not always coming in the same way or shape. And right now your code, it's still working, doesn't matter how the data came to us to that point. We were able to read 1 year worth of data and compute the standard deviation over time without knowing pretty much anything about the data. Of course, the caveat is there has to be, have some kind of metadata in your input data. But once this is done, the software is smart enough to do that for you. So we figure a lot of things out as long as we have the metadata. Now I'm going to create a canvas. So I'm initialize a new canvas to plot in using VCS. And then I can just tell him plot me this data. And again, because we have metadata, and the software can take advantage of that, and it will realize at that point that, like, oh, these have latitudes and longitudes, and I can plot that on, it's like a Earth data, so I can put the continents on it, and I can do all these things for you. So we could use projections, orthographics or whatever we want, polar. It would be able to do that for us pretty much for free. And the default graphic method is box fill, but we have 1D and we have a 3D plots, isofill, isoline, we have mesh fill, which is basically plotting the data on the native grid. So that's for curvilinear grid or polar grid, things like that. Taylor diagram, vector plots, and everything. And you also in VCS have access to the such as shape, text, so you can add things to your plot. So that was a little data. I'm going to go back because I forgot about it. But basically that plot is what you get. And as you can tell, he was able to tell us that it was a lat long plot. He put the continents on it. He told us, the latitude and longitude. That is at minus 180 to 180. It's figure out where it was read. Give us our mean, our maximum, minimum. Tell us where we're putting the standard deviations. And we have a color bar. So really, all that work's been done in, let's see, 1, 2, 3, like in 5 lines of actual code. We actually are able to read in data, do a standard deviation, and plot it. And 6 lines if you want to save the ping, as I do here. So other projects that are using UVCDAT under the hood, the Earth System Grid Compute Working Team is going to use UVCDAT to do all of its computation server side. So again, for us it'd be very easy to implement the new diagnostics. CDAT Web is now called VCDAT. That's a new GUI, basically server side. Browser to do the GUI. We have the Uvc Matrix, which is using CDAT to compute a bunch of statistics from output model from the Accelerated Climate Model Energy Initiative, something like that, ACME, which is a DOE climate model. So basically they use UVCDAT on their output to generate diagnostics and evaluate their simulation and decide, if the model is doing better or not as good as before. Another project that has a similar thing is a PCMDI, which PCMDI is a program for climate model diagnosis intercomparison, and they use CDAT to do a set of metrics, as well on all the CMIP, which is a coupled model intercomparison project. These data are used for the IPCC, Intergovernmental Panel on Climate Change, and that's this report that leads to treaties like Kyoto and stuff like that. So they use CDAT in the back, same thing, to do some of the statistics and determine, how good or bad the model perform, and then use that into the reports. Future webinars, just for anyone, I could go way more in depth because you said about half an hour, so I'm trying to stay at about a half an hour presentation, but we can go in much more in depth on that. So there's a very, 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 very bare bone, what we do. Now let me just, oops, exit from that. I'm going to go on my Mac. Okay, do it from here. You see, I'm doing a lot of things all the time, but I'm just going to show how you would install. So you do conda create minus name, test, for example, and minus channel UVCDAT, package UVCDAT. I know that I want PyQt. So okay, PyQt equals 4.11.3 because they changed PyQt lately. I want to make sure it's a good one, and HDF5 equal 1.816. So I'm creating a conda environment on my system. Now it's going to talk to conda, figuring the package that I need. These are all the package and dependencies that are going to be installed and required. So you see, you get a lot of stuff.
So Charles, when you specified a specific version of HDF, that is to make sure that they haven't upgraded and become incompatible or something?
Yes, it's because when I just released UVCDAT, I was using, adjusted HDF5, and I didn't pin it to 1.8.16, and then HDF5 went to 1.8.17, and it's totally compatible, but HDF5 has this thing that if your software has been compiled with older versions, it just barf out on you instantly.
Sure.
So now I have to pin it. I should have pinned everything, when I released it. That was my mistake. I'm still new on Conda, so I'm learning.
Oh yeah. I guess you could also use an environment.yml file, I guess. Anyway.
Yes, I could do that as well.
Okay. Anyway.
And, so here we go. So now I can just simply do source activate test, and here we go. I got a brand new environment with CDAT in it. So that was about what, 2 minutes top to get it on your system. And now I can just do, Python and things like that. And wow, it's smoking in the back.
Does it work only on?
Oh, I didn't know the data. Yes.
Is it 2.7? Does it work on Python 3, or we're at 2.7?
It's no, we are still on Python 2.7. We can do the jump to Python 3. It's another thing we're thinking about, but I admit it, I'm scared.
Yeah, okay.
Because moving to Python 3,
Yeah.
being going to take a month or two of breaking things. And just but I think Python 3 now is mature enough that we can actually jump.
Yeah.
It's been a while. I mean, when Python 3 came out, I remember talking to the Python people, and they were expecting about 10 years until you really replace Python 2.7, because you need time, you know, for all the basic modules to be ported, and and then the module that depends on this module and the package. And since we depend on so many packages, for us, we're pretty much at the end of the food chain here.
Yeah, I gotcha.
So anyway, now I have a bunch of data. So I probably have this file name, which is the same one. I can do F to CDMS to the name. So I can, like, can you guys see my screen at least, or is it too small? Should I make the font bigger? I might want to do that.
I think we can see.
You can see, okay. I just see if I can quickly.
Yeah, it's fine.
That's okay.
It's fine the way it is.
It's fine like that. Okay. We can go up at 24 maybe. Here we go. That'll be a bit better. F dot variable keys, you know, that would tell me all the variables that are in my files. Then I can do cloud equal f of cloud. So that's what you were asking earlier. So like if I do a square bracket, I didn't read anything in memory.
Okay.
But now I have kind of like a, so it's telling me the shape.
Yeah.
And this dimension. What dimension? No, it's on the file, sorry. So that's the dimension in my file. I can do cloud get axis list. That's what I wanted. So these are the axes on my file. So you see I have time from 79, all of that. And I can do import this, yes. I'm just reviewing quickly the plot we had, but I want to make it a bit nicer. This is in it. So that's the basic plot. Comes in the back here. So that's just a normal, you know, cloud plot of sorts. But then we can create object, you know, like isofill equal this is the create isofill. Fill. It's there. That's this. So that's all the attributes I can set on my ISO. Let me clear my plot, and I can plot that using the ISO field now. And somewhere in the back, yes, you know, I've got an ISO field plot. We have, I didn't mention, but we have a lot of reading capabilities. So if I do, okay, U equal F of U. U is a wind, westward wind, I think. U dot info would be faster. You give me the information on my U. And oh, yeah, long name is empty.
So Charles,
yes.
this is using to understand how to do the indexing on these different coordinate axes.
Yes.
You're using the CF conventions?
It's, yes, that's based on CF conventions. If your data are CF compliant, you don't have to be 100%. I mean, the closer from CF compliant you are, the more power you'll get out of the tool.
Yeah. Okay.
Yeah, go ahead.
I'll let you finish this.
No, I just want to show, like, I'm basically going to fill my data. So now, like this is a pure NumPy array, and I can still plot, you know, a pure NumPy array. But then you got, you know, basically there's no smartness. See, that's the difference between having just an NumPy array and now it's just indices, you know, 0 to 72 and 0 to 45 and boom. versus versus if you have data with metadata on them, now you can actually have all the information you need. So that's the difference. Yes, go ahead.
Well, I was just going to ask if you have, say, like in oceanography, we have a lot of curvilinear coordinates,
yeah.
so that, you know, our latitude and longitude are not just 1D coordinates. Is there anything that
yeah, let me see that. I have a file, fname, fname what? Let me get out of just regular Python and use Really? I didn't install Python on this one. That's a good thing about Conda, you can always add packages.
Yeah.
I like IPython better.
Sure.
Because it auto-completes stuff. So, okay, so now I get that, I have my data. Come on. So you have a fname curvilinear, so that's what you're mentioning, that it's a curvilinear grid.
Okay.
It's one of our sample data. So cdms2.open fname curve. I think it's called sample. So I'm reading the sample data. And okay, I think that right bat is going to be able to plot it. Yeah, here we go. So C was able to plot, but it noticed you already have latitude and longitude. But then if you create a mesh field, which is what we use, create a mesh field, and that mesh equal yes. See here. Yes. See, it's just now you can see your grid.
I see.
So, and you can actually do m.projection polar. I think that should work. See, it's able to project your grid. Well,
cool.
not the best view, but yeah.
Yeah.
So all these things, we do a 3D plot. We have Gary. Oh, I wanted to show the regridding. So, oops, new that shape. So this data. Oh. Yeah, let's put up cloud. Actually, let's do. So S is still my data, you know, on the curvilinear grid, and I can do s.regrid u.getGrid. So now I use the SMF regrider, and my data is now on the grid of my wind. And see, now it's a regular lat-long grid. So I can compare it with other data now much more easily, do new addition, subtraction, and all that. And it's been done, again, that's the power of the metadata. It's been done entirely for you for free. Simply by, let's say, regrid to the grid of that data. And you can go either way. You can go from U to S, S to U, things like that.
Cool.
So yes, that's really the nitty-gritty of UVC that in 30 minutes.
Awesome. So everybody, if anybody wants to ask a question, I think probably most people are muted, so you have to unmute yourself.
Yeah.
Anybody? Well, I wanted to give other people a chance before I start asking questions myself. So how, there's sort of it seems to me there's like a kind of a mind-numbing number of different climate tools out there, and you know, some of the ones I guess that like we heard about at SciPy were things like the X-Array package, and the British Met Office has a package called Iris. This is in the Python world anyway. And
Yes.
yeah, and could you describe sort of how to view like UVCDAT and X-Array, and I mean, do you have a good take on that, or are you familiar with those tools at all, or?
Yes, I'm familiar with them. I think, okay, one big difference of all these X-Array, or they usually are specialized in one thing or another. It's more like X-Array is more like what CDMS brings to you, and some VCS is more for the plotting and things like that. Whereas what UVCDAT gives you, it's basically a one-to-end, start-to-finish environment.
Yeah.
You have all the tools you need to do that. You don't need to go look for another package here or there. It's complete. It's a complete suite. Where most of these other tools out there, they are very good at tackling one thing maybe, but then once you're done with that, you're going to have to go look for another solution to do the next part of your analysis, and that is not necessarily going to play well with what you just did before. Whereas UVCDAT, everything works very smoothly together, because we have the same philosophy. You know, from reading in the data to analyzing them to plotting them, everything speaks to each other and talk. And so you can use either one of these packages, you know, separately, just like the other tool you mentioned, but they also work, they play really well together. So I think that's the biggest difference.
Okay.
It's really everything. I think personally, but I mean, you know, I'm super biased, but I think it's much easier than most of the other package. It's got, I mean, I don't know, but for example, Matplotlib or Cartopy or all these things, plotting geodata is not easy with it. I mean, you will need a lot more line of code just to do the CLT plot I did than just 3 lines. You need to figure out your grid, you need to create your spatial axis, you need to create your grid array, and, you know, it takes, you know, it's not easy.
It seems, you know, I know that one of the raps against CDAT used to be that, oh, it's gosh, it's got so many dependencies, it's so hard to build. But now
Yes.
I guess Conda has just really
Conda really, like, yes, for us it was a game changer completely. And I have a lot of people now that came to me, I'm like, oh my God, thank you. Why didn't you do that earlier?
Yeah. And now I guess not only that, like, not only is it easy to build, but now you could easily have your CDAT environment like you created, and then your Iris environment or whatever, and
exactly, yes.
yeah, and you could, you know, it's easy to switch now between those, and
exactly. It used to be really hard to install, and I admit it, and when you had it, people sometimes were frustrated because, like, well, listen, I've been using Python, but now I don't have, you know, package A or package B, and why don't you support that? And I'm like, because I can't support every single package in the world, because it's already hard enough to build like that. You know, we have to get done at some point. So now we still have this very rich environment, but if we missed out your favorite package, you can still, you know, add it to yourself very easily. So Conda really helps us work with that.
Yeah. Okay. Well, I think that was an excellent short introduction to CDAT. And does anybody else have any questions? I guess this might have been a deeper technical dive than some of our community are used to, but I sure enjoyed it.
Oh, I'm sorry. I didn't.
No, I mean, no, it is. It was. You know, it's exactly right. I mean, we have a bit of a light turnout today, so some of the more the folks who might normally be asking questions perhaps are going to be watching later, I suppose. But I think, no, that was pitched actually just exactly right. We didn't want just a high-level summary. it's good to get into really into the technology of how it works and what its capabilities are. And
yeah, I was trying to tell, you know, kind of near the surface still. Too deep.
Yeah. Without diving into no, that was perfect. Okay. Yeah. In fact, I'm getting a question here. Do we have a recording? And yes, we do have a recording. And the recording will be made available through the website, which the ESIP. If you just Google on ESIP Tech Dive, that's probably the easiest way to find our page. And as soon as this is over, we'll convert the recording and put it up on YouTube and put the link on the web page. Okay. Well, I'm going to assume then that there aren't any other questions, and so thank you so much, Charles, for taking the time to give us this presentation, and hopefully this recording will be useful to you guys too in the future for other folks who are interested in finding out a little bit more about CDAT.
Don't hesitate to call us, join our mailing list, or, you know. Yep.
Okay. All right, thanks everybody, and we'll be back on September, the second Thursday of the month, so that will be September 8th. All right, thanks again. Bye-bye.
Thanks, guys.